Question 10, and this one's a differential equation question. So it said the height above the ground, h meters, of a passenger on a roller coaster can be modelled by the differential equation dh by dt equals that there, h cos 0.25t over 40, where t is the time in seconds from the start of the ride. Given that the passenger is 5 meters above the ground at the start of the ride. Right, so what that's telling us, I'm going to stop reading there because a key bit of information here we're being given, so we should write it down. So that's telling us that when t equals 0, i.e. at the start of the ride, the height, h, is 5. So it's telling us that piece of information there. So part A says show that h equals that there. So basically it's asking us to solve this differential equation subject to these initial conditions here, sometimes called boundary conditions. So when solving a differential equation, the first thing we should do is split up the differential into two parts by timesing by the denominator of the differential. So that gives us dh equals h cos of 0.25t over 40 dt. So we've multiplied by dt there. Next step, we want the h's on the same side as the dh and the t's on the same side as the dt. Well, luckily we've already got the t's on the right side. All the t's are on the right hand side, as is the dt. However, the h needs to go to the other side. So that implies that, and if we divide by h, we get 1 over h dh equals 1/40th cos of 0.25t dt. And now we're ready to integrate both sides. So we integrate that side and that side. We've got the integral of an h dh and the integral of the t's dt. So that implies that log mod of h equals, and then the integral of cos is sine 0.25t. But it wasn't just cos t we were finding the integral of, it was cos of 0.25t. So we need to divide by the differential of what's in the bracket. So we need to divide by 0.25, divide by a quarter, which is the same as timesing by 4. So I'm going to turn that 1 into a 4 on the top, plus c. So then to summarise, log modulus of h equals 1/10 sine of 0.25t plus c. So we're almost there. Now we need to find what c is, so we're going to sub in at this point these initial conditions here. So t equals 0, h equals 5. So let t equal 0, h equal 5, which implies that log of 5 equals 1/10 sine of 0 plus c, which means that c is log of 5. So finally we can conclude, therefore, well, not quite finally, but log mod h equals 1/10 sine of 0.25t plus log 5. So now we e both sides. The left hand side becomes h over 5 equals e to the power of, and rather than a tenth I'm going to write 0.1 so that it fits nicely in the power, sine of 0.25t, make that a smaller bracket, which implies h equals 5 e to the 0.1 sine of 0.25t, which is what we were asked to show. There it is there. So h equals 5 e to the 0.1 sine of 0.25t, which we've got here. So the next part, which I've just written here, copied here to remind us what it is, says state the maximum height of the passenger above the ground. Well, we've got to think now what's going to give the maximum value of this. Well, the maximum value of this is going to occur when this part here, sine of 0.25t is equal to 1. That's going to be the biggest value. So let sine of 0.25t equals 1, which implies that h max, i.e. the maximum height, is 5e to the power of 0.1. So we want to give that in practical terms. 5e to the power of 0.1 equals 5.526 meters. Which, to be honest, makes for a pretty crap roller coaster if it starts 5 meters and only goes half a meter higher. Bit rubbish, really. So then let's answer the last part. Let's paste it here to remind us what it is. So the passenger reaches the maximum height for the second time, t seconds after the start of the ride. Find the value of t. Okay, so we want with sine of 0.25t equals 1. Sine 0.25t equals 1. Well, if we arc sine both sides, we get 0.25t equals arc sine of 1. Make sure the calculator is in degrees mode now. Sorry, radians mode, because the question's in radians. Anything to do with calculus is always going to be in radians when you're integrating or differentiating, that is. So the angle unit we want to be radians. So arc sine of 1, and you should know this, you should know it's pi over 2, but it's always nice to confirm. There it is, half pi. So equals pi over 2. So I draw the graph quickly, rough as you like. So the next time it's there again. So that was pi over 2. Pi, 3 pi over 2, 2 pi, and then there's 5 pi over 2 is the next time. So 5 pi over 2, which means that t equals 5 pi over 2 divided by 0.25, which is equal to, well, dividing by 0.25 is the same as timesing by 4. So times by 2 and 2 again gives 10 pi, which is 31.42 seconds. 31.42 seconds is the time that it reaches the maximum height for the second time. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.